Welcome to the second in this series of videos where we're dealing with simultaneous equations. In the first video, we had the same equation and we pivoted on the x variable. In this video, we're going to use the same pair of equations and instead we're going to pivot on the y variable. Notice I use in particular types of vocabulary here, right? The reason I'm doing this is because in using the words that I use, I want to kind of throw ideas into your mind so that you could get a vivid picture of what we're doing, and the idea being that that would enhance the understanding of the topic. So right, we're going to pivot on the y variable. What do we mean when we say pivot on the y variable? All it means is that having a single coefficient here, the single coefficient of course being negative, being that we have minus 1y here, the 1 of course being understood. Alright, recall in the first video we had the x here, the 1x, and we pivoted on the x variable. So here we're going to pivot on the y variable, seeing that we have a unitary coefficient, a singular coefficient, a coefficient of 1. That's the idea, right? You have a coefficient of 1. So we go in. 3x minus y is equal to 9. So you want to make y the subject of the formula. So the first thing you do is take the plus 3x and I carry it over here and you get minus 3x. So you'll get minus y is equal to 9 minus 3x, and then you multiply throughout by minus 1 and you get plus y is equal to minus 9 plus 3x. In other words, all you do is just change the signs. Or alternatively, what you could have done was simply take the minus y from the left side here, carry it across on the right side, which will give you plus y, and then you take the same 9 here and you carry it across on this side to give you minus 9. So what you would have in effect gotten would have been 3x minus 9 is equal to plus y, which is what we have here. We just have it switched on the other side. Alright, so I want you to be very careful here, because this is the first opportunity that you have to make a mistake if your algebra is not on point. Good? Especially where the signs are concerned. You know that every time the minus sign shows up, life becomes a lot more interesting in this maths. Alright, so just to go this over very quickly again, 3x minus y, the simpler method, and I'm going to explain this again just because we don't have it on the board here. 3x minus y, you take the minus y and you bring it across here to give you plus y, and you take the plus 9 and I carry it over here to give you a minus 9. You could do it in one step if you want, or you could do it in 2 steps if you want. If you're not too sure about it, my humble advice would be to take 2 steps. The extra line is always better, if you need it, that is. So having gotten y is equal to 3x minus 9, you substitute that into equation 1, so that you now have x plus 2 by whatever the value of y is. Right, we have it here. We now insert in the value of y here. X plus 2 into 3x minus 9 is equal to minus 4. So you do a little expansion here. X plus 6x, 2 by 3x is 6x, 2 by minus 9 is still minus 18. So x plus 6x minus 18 is equal to minus 4. So you have x plus 6x. You take the minus 18 from here and you carry it across here to give you plus 18. So x plus 6x is equal to 18 minus 4. Of course, we know that 18 minus 4 is 14. We know that x plus 6x is 7x. So from here, we go to here, and we have that 7x is equal to 14. If 7x is equal to 14, then x naturally will be equal to 14 divided by 7, which we know is equal to 2. And now you substitute x equal minus 2 back into equation 2. Again, just as was the case in the first video, it doesn't matter at this point whether you substitute the value that you found into equation 2 or equation 1. Okay, so we're just using equation 2 here, but again, you could challenge yourself and see if you could substitute it into equation 1 and get the same answer that we have here. So you substitute x equal 2 into equation 2. You'll get that 3 into whatever the value of x is. 3 into 2 is still 6. 6 minus y is equal to 9. Look, we have it here. And here now, you take the plus 9 and you carry it over here, you get minus 9. Then you'll have 6 minus 9. You take the minus y and you carry it across here and you get plus y. So if you need to take this here and work it out in 2 steps, 2 extra lines, 2 lines instead of 1. Alright? If you need to get somebody to help you to show you, then by all means do that. But I really want to encourage you to challenge yourself. Sit down and do it. Don't just feel that, okay, I watched the video, understand it, and I understand it. No, that is not how maths works. Maths is not a movie. Maths is not some kind of cinematic production where you sit down in a seat, you enjoy it, you be edified, and then you go home afterwards. Understanding it is the first part. Then you have to practice, practice, practice. It's like any technical skill. There's no way you could say that you understand it if you can't reproduce it when called upon to do so. Alright? So, x, 6 minus 9 is equal to y. 6 minus 9 is still minus 3. So, your y is equal to minus 3, which is to say then that x is equal to 2, y is equal to minus 3. End of discussion. That's it. We finish with this particular equation. Alright? So, just to recap. In video 1, we pivoted on the x variable. We found the value of x and we substituted it into equation 2 to get another equation in terms of y. And then having found the value of y, we substituted that value back into either of these 2 equations to get the value of x. In video 2, which is this video at present, we pivoted on the y variable. From equation 2, we found the value of y, we substituted it into equation 1, and then we got an equation in terms of x. Having found the value of x, we would then substitute the value of x into either of equations 1 or 2 to find the value of y. Now, video 1 and video 2, we dealt exclusively with the situation where you have a unitary coefficient. You have either 1x, or it could have been minus 1x, or minus 1y, or plus 1y. Alright? So anytime you have a pair of simultaneous equations where you have a single coefficient, either plus or minus 1x or plus or minus 1y, then your straightforward substitution is the easiest method to apply. You just find the value of x or y from the equation in which it appears. You substitute it accordingly, find the value of the other variable, y or x, and then substitute that value back into any of the 2 equations to get the actual value. And that is basically it. So I hope up to this point that you have been learning something, if in fact this is a topic that would have caused you problems before. In the next 2 videos, we're going to deal specifically now with the situation where we don't have a unitary coefficient. Alright, and if you're not sure what that means, stay tuned. Video 3 is coming up next.